Greetings and welcome. The man behind the screen is Tinashe Nyika, who provide online lessons, and I enjoying being with you, helping you to prepare for your exam. And it might be for entertainment. For you, maybe you don't have anything to do, and you can just watch this and to refresh your mind, or you are preparing for any exam, no problem, because this one is for free. So let's go to the slide where I can be able to share. So today we are going to approach a concept where we are talking about the climate, but we start by examining the structure of the atmosphere. So the most bottom layer of the atmospheric structure is the troposphere, where we have 80% of the gases belonging to the troposphere. And those gases include water vapor, include dust particles, include the carbon dioxide, methane, and other trace gases that are found in smaller quantities. They belong to the troposphere. Okay, in this area we have maximum. Usually, it is the area that receives maximum heat because of the radiation of the ultraviolet long wave radiation to the atmosphere, back to the atmosphere. Okay, so this is actually the area where we consider to be an area that produces much heat. It is also an area of all weather, an area or a region of all weather. All weather actually takes place at the troposphere. Okay, let's brief on to what we call the stratosphere, where we have 19.9% of the atmospheric gases belong to the stratosphere, and temperature is actually constant until 20 kilometers. In this area, we have the ozone gases being dominant, and this is the area where we actually know that it's a zone that's protecting us from receiving extensive heat from the sun. So at this area, we also have strong winds blowing, and those winds, we call them jet streams. So this is what we call the troposphere. So this area, the stratosphere and the troposphere, is much related to the environment and much related to our life here on Earth. As it creates weather, it disturbs the climate that we actually know. But this is due to our participation, erection and production of carbon dioxide and other gases that are emitted by our environment. Okay, so move on to what we call the mesosphere, where temperature actually decreases with the height because of the decreasing density. As we go up there, there's less air above us, therefore the air density becomes low, and we have the strongest winds blowing that side, and the temperature actually falling so much, about minus 90 degrees. Okay, so move on to what we call the thermosphere, the last zone of the structure. The thermosphere, we are saying the higher we go now, the hotter it becomes. It's very much opposite to what happens in the troposphere. This time, the higher you go, the hotter it becomes. So temperature here reaches about 1.5 degrees Celsius, and we have atomic oxygen actually very much concentrated in this region, participating in the heating and burning in the atmosphere. Okay, so atmospheric gases, we also have the nitrogen and the oxygen that makes 99% of the gases, and we have the carbon dioxide that have got 0.037% participation Okay, and this carbon comes up from the carbon cycle. It comes from respiration. If you have studied the carbon cycle, you understand that industries produce carbon when the bodies or animals die. They produce carbon. When we breathe out, we produce carbon. Those are the areas we all have water vapor. Let's move on to what we call the energy budget. Energy budget. Okay. We have different heating resulting in the creation of the air currents. Different heating at different places actually result in a creation of air currents, because some of the areas, some of the regions, you've got the surface characteristics that absorb more ultraviolet rays or more insolation as compared to other areas. Maybe we can consider an area that you've got a rock type that absorbs more, that is darker, that absorbs more insolation, and the other rock type that is light, it actually reflects much insolation, and resulting in a variation of the heating. That variation can result in the creation of air movement. We can get into this deeper as the lesson unveils. So we can understand that when we are talking about the budget, we are saying the insolation, the incoming insolation, and the outgoing radiation should be, the net radiation should be zero. When we have equal insolation, radiation is equal to outgoing terrestrial radiation. Then we have what we call the zero, where we have the balance heat budget. Okay, so we have some particles that exist in the atmosphere, like the dust particles. Those can work to reflect the ultraviolet rays. We have the clouds. Usually, when it is cloudy, you can't actually see what is. You can't see the sun. It's dark. It's shadow. So it also participates in the sun, amount of sun that reaches the ground. Okay, we also have different areas, like we have the land in the water. Usually the land got a high specific heat, which means it actually need the land actually need less energy to get heated to 1 degree, and water needs more energy to get heated to 1 degree. So these the two elements heat at different rates. Consider the sun has been burning, had been heating since morning until 3 o'clock, and if you check, you see that the land will be more hot or more warm than the sea or the water. So what happens? The warm air leaves or becomes light and moves to the direction where we have the cold air. So at this time during the day, what air moves from the land to the sea or to the water. But during the night, water uh, is slow to gain heat, but is slow also to release heat, which means water during the night it will be warmer, and the air moves from the water to the land. And that movement creates what we call energy budget or energy budget balance. Sorry. Okay, so this is scattering. I've been telling about scattering, and I said scattering is when the sun's rays is redirected to all different angles without the change of the ultraviolet or the ultraviolet wavelength. There's no change of the wavelength, just the redirection of the sun's rays to all the angles. Okay. We have what we call reflection. Reflection, we can see it on shiny surfaces or smooth, light surface, light colored stuff. when the sun's rays hit on a straight line and redirected on another angle without the change of the wavelength. Okay, so this is now different from scattering in this fact that reflection only directed to one direction, but when it's scattering, it actually redirects to different directions. Okay, this is the summary of the structure of the atmosphere, where we have the troposphere, stratosphere, mesosphere, and the thermosphere, which is the topmost layer. But we actually said these two is where usually our weather belongs. These two is where our weather belongs. If we tamper with our production of carbon dioxide here, it results in the destruction of the ozone layer that results in us receiving much insolation that can make the Earth a very difficult environment to survive in. Okay, so let's move on to what we call reflection. Reflection, we mentioned something here. So let's move on to what we call a greenhouse effect. A greenhouse effect, we are talking of the environment where we have insolation is allowed to penetrate inside in shortwave radiation, but it is not allowed to live in long-wave radiation. When insolation is allowed to get in, without it allowed to get out of the stuff, that means there will be extra energy inside the thing. Consider you left your car outside on a sun environment. You left it with all your windows closed, and the sun is continuously hitting the shortwave radiation. Shortwaves will just continuously penetrate into your car, but the long-wave radiation cannot leave the car, resulting in excess heat in the car. When you open your doors, you will see that the first thing you do is to switch on the aircon because the temperature will be very, very high. That's what we call the greenhouse effect. In actual sense, we are saying this greenhouse that we have at home, it also is a symbolisis of the greenhouse effect that I'm talking about, where we have a blanket of these gases, the carbon dioxide and water vapor, is accumulating above us, and it doesn't allow long-wave radiation to penetrate out of the Earth's surface, resulting in too much heat accumulating on the troposphere. Okay. Then we have the polar heat transfer. The polar region being the very cold area on this planet Earth, 60 to 90 degrees north and south. We have the area that is actually known to be a high pressure area, where we actually know that the air from there blows to the tropics, blows to the 60 degrees, blows away. That is the high pressure, blows away to rushing to the low pressure zone, maybe on the direction of the equator. Okay, because of the Coriolis force, it is diverted to the right in the northern hemisphere and to the left in the southern hemisphere, creating a wind pattern. And those movement of air from that cold region to a warmer region transfers heat and cold, resulting in the balance that we are talking about. Okay. So that is what we have to cover for today, since this is an introductory lesson. I am also inviting you to check on my YouTube. You can check on Thinkific, Tinashe at thinkific.com. You find me. You can also find these videos. You can also find the learning materials there that can also help you to accomplish or to make it right with your exam and be friendly to your learning stuff. Okay, let me hear from you when you watch this video. Maybe you want to give a contribution, maybe you want to comment, and everything's just welcome for the development and the betterment of a future presentation. I thank you.